As the world strives to lower its greenhouse gas emissions and go carbon neutral, countries must find clean, sustainable sources of energy to replace sources like coal, oil, and natural gas. The time has come for action, if not for our sake, then for the sake of our children and grandchildren. We have the responsibility to leave them an environment better than we came into, which is well suited for their flourishing. To do this, we must find clean and sustainable energy sources to power our civilization. While there are many possibilities for successors to coal and natural gas, one energy source, I believe, rises above the rest in potential to reverse the degradation of our environment and future, and that is nuclear power. And this is no different for the U.S. We must expand upon nuclear power substantially to accommodate our rising electricity needs. Nuclear energy is an underrated, untapped, virtually, and underutilized resource which holds vast potential and promise. To explain why the U.S. must go nuclear in the future, I will go through its superiority in regards to three criteria: reliability, output, and waste products. First, let's look at nuclear power's reliability. Nuclear's reliability is quite extraordinary and vastly superior to other clean energy sources. For one thing, it operates regardless of weather. It can operate at full capacity all the time. It's not like solar power, where you need the sun to be shining for it to be working, or like hydropower, where you need the water to be flowing and high enough for it to work, or like wind power, where the wind needs to be blowing for it to work. Nuclear can work at all times, regardless of any conditions outside of the plant. Nuclear energy is the most reliable source of clean energy, and any other energy for that matter. According to the Office of Nuclear Energy, nuclear has the highest capacity factor of any other energy source, which in nuclear's case means, and I quote, nuclear power plants are producing maximum power more than 93% of the time during the year. That's about 1.5 to 2 times as much as natural gas and coal, and 2.5 to 3.5 times more reliable than wind and solar plants. Nuclear just keeps pumping. Another asset to reliability is the plant life, which extends from 50 to 80 years and longer. This is much longer than the average lifespan of solar panels, at 25 to 30 years, and wind turbines at around 20 years, or even coal at 40 to 60 years. While the cost of nuclear energy is high as far as building plants goes, at $5,000 or even more per kilowatt compared to $3,500 per kilowatt for coal, nuclear is just so reliable and low maintenance and designed to run almost forever, it pays for itself. Reliability, as well as other factors, make nuclear energy's output very high and promising. So, nuclear energy is also the right choice because of its output. Even now, as nuclear is underutilized and underappreciated, it has produced a fifth of the U.S.'s energy every year since 1990. In 2020, nuclear produced 790 billion kilowatt hours of electricity, surpassing coal's output for the first time ever. As far as clean energy is concerned, nuclear produces 52% of the U.S.'s clean energy in 2020, making it the largest domestic source of carbon-free electricity. Nuclear produces more energy with less. This is not only because of the sheer output and energy density of nuclear fuel, but also because of the capacity factor as discussed above. Because of how reliable and consistent nuclear energy is, a 1 gigawatt nuclear plant would need almost 2 coal plants or 3 to 4 renewable plants of the same output to replace a single nuclear plant. The average nuclear plant uses 27 tons of fuel a year, compared to 2.5 million tons of coal to produce the same amount of electricity. There's vast amount of nuclear fuel still to be used, which could power the U.S. very easily for hundreds of years, either with or without help from other renewable energy sources. Even the whole world for almost 200 years at current consumption rates. Despite high energy output, waste products are very little. Nuclear energy is the right choice because of this. Its minimum waste products are second to none compared to the other sources of electricity. As far as nuclear waste goes, very minimal. Over 6 decades, which the U.S. has used nuclear power to produce 20% of its electricity. Actually, that was 1990 onward. Anyways, 6 decades worth of nuclear fuel for the U.S. fits in a football field 10 yards deep. At least it would if it was put in the field. This is 60 years worth, running at almost constant full capacity. In other words, it's 83,000 tons of nuclear fuel. Sounds like a lot, but compared to other energy sources, which surpasses 83,000 tons of waste in but 4 years, or coal, which surpasses that in a day or less, it is extremely small and very manageable. Remember that this is 60 years worth, at full steam ahead, almost constantly, and only 83,000 tons of waste. Now, moving on to greenhouse gas emissions as far as the waste goes. Nuclear energy produces no greenhouse gases at all. CO2 and other greenhouse gases are not byproducts of energy production for nuclear. And on another note, with nuclear waste, it is not as damaging, well, it's very damaging, but not as dangerous as many fear because it is relatively easily contained and stored underground. And taken together with the fact that the waste produced is very minimal, it goes towards just another reason for nuclear to be utilized more for the U.S. in the future. Nuclear is the right choice. As you can see, nuclear is the right choice for the U.S. to produce electricity for many reasons, in this presentation pertaining to reliability, output, and waste products. It is clear that nuclear is underutilized and underappreciated, and could be expanded upon to help power the U.S. and the world. The world must do something to avoid climate change, and it is abundantly clear that nuclear energy must play a large part in reducing greenhouse gas emissions. For the sake of future generations, we must rely more heavily on nuclear. As we move forward, is it not the most prudent thing to do to expand upon a tried and true, powerful, sleeping giant of an energy source, to power us into transitioning to sustainability?